So this question is coming from second theorem, and then whenever answering questions from second theorem, start by always knowing the theorems. So please know the theorems before you answer the questions on second theorem. So for instance, in this case, we are given to say we have a, x, o, t, y. So you've been given that here there is what? 4x. So if you have a 4x here, meaning that you can be able to get the angle which is there. Using theorem what? The first theorem, which is theorem 1. So there's a theorem which says that angles at the center are twice angled at the what? Circumference. So if here we are given 100, meaning that that will be what? A 50, not so. So meaning that if here we are given a 4x, there we should have what? A 2x. So meaning that here we are going to have 2x. How are we getting it? We are saying 4x divided by what? 2. Have you seen that? That's how we are going to get that 2x there. Then from there, you can also say that, look at this, you can also use theorem 6, which says that if you have a circle like this, you have a radius and you have a tangent. If you have a radius which is touching the tangent, if this is our radius touching the tangent, meaning that this angle should be what? 90 degrees. That is theorem 6. So in this case, we are having this radius here, which is coming from the center, touching the what? The tangent. Is that okay? Meaning that this angle this side will be what? 90 degrees. By the way we solve second theorem, right? When you find a question on second theorem, don't just go direct to the questions. Don't do that. You will not be able to find the answers. Instead, first try to solve all the angles that are inside. That's when now you go to the questions. You're going to find that the question becomes even very simple. Don't just go direct to the questions, because some questions you'd find that for you to get maybe a certain question, you'd find that maybe it will require you 5 steps for you to go to that particular question. So no wonder it's very hard for you to just go direct to the questions. Instead go to the what? To solve all the angles inside. So we've gotten this angle here to be a 90 degrees. Is that okay? Then after we've gotten that this angle is a 90 degrees, you've also seen that you have this this shape here, which is a quadrilateral. You see now? So angles in a quadrilateral add up to 360. If you have x here, you have 4x and 90, meaning that you can be able to get that remaining one there. Is that okay? So you come here to say, so let me just get my duster here. So you come here to say, so you should always show your solving. Always show your solving there. So you say, I'm getting angle what? OXA. So you can say I'm getting OXA plus what? Plus x. Then plus also what? 90. Plus what? 4x. We should be able to get what? 360 like that. Then we add. This is the angle OXA. We can take, for us to get angle OXA, we can make it the subject of the formula, not so. Making the subject, we are going to say is equal to 360 minus 90 minus x minus what? 4x. Have you seen that? I want to get this angle, so I'll take all these numbers the other side of the equation, so that I remain with the angle. So in that case, we are going to say angle OXA is equal to 360 minus 90 is what? What's 360 minus 90? That is 270. So 270 minus x minus 5 is what? Is minus 5x. So meaning that this angle which is here, you can even write it to say it is 270 minus what? 5x. So you say 270 minus 5x like that. Are you seeing how we are getting the angles? So they have gotten that angle there. Then what you can also do is to get the angle which is, so we've gotten this angle, that angle, that angle, that angle. Then we can also get this angle which is here, which is the smaller one. We can also get this one. So these are the only angles remaining. We are only remaining to get this angle here and also the angle which is this other side here. Is that okay? Now how can we get those two angles? So what we are going to do is we are going to say, we are going to do this. You know that if this is the radius, we are saying that from here to here is what? 90 degrees, which we've already written there. Then also from here to here also it would be what? 90, because it is also already touching the tangent, so that we complete the 180. So 90 is 180. Is that okay? Now, what we are going to do is that, remember I'm saying that we are fighting to get this small angle, which is from here to there, you see now? That small angle which is there. And also we want to get also the angle which is only from here to there. That's what we are fighting for, like that. Now, what we are going to do is that for you to get those small angles, maybe is there anyone who can help me how to get any of those angles, either like a small one or this one? Any theorem you can use? Madam Long. Okay. All right. So what we are going to do is this, Okay. So what we can do is this, the simple one that we can use is, I don't know if are you able to see this triangle here? Have you seen the bigger triangle? Have you seen that? Angles in a triangle add up to what? Have you seen? So we know this, we know that, we can get which one? That one, because if you know the total, we can now we can get the smaller one, because we know that from here to here is 90, so we can now get the smaller one. So we are going to start by getting the whole lot of the angle, which we are going to say angles in a bigger triangle add up to 180. So we are going to say, when we add x plus 2x plus angle what? ATY, not so. Angle ATY, this bigger angle here. We should be able to get what? 180. Is everyone okay? So now from here we are going to say x plus 2x is what? 3x, right? So we can make angle ATY the subject of the formula, and this will be equal to 180 minus what? 3x, not so. X plus 2x, which is going to be minus 3x here. And then we are going to say angle ATY will be equal to 180 minus 3x is what? What is 180 minus 3x? It will remain 180 minus 3x, not so. So 180, that's why we can just end there. 180 minus 3x is our answer, because these are unlike terms. You see, right? So meaning what we found is that the total angle from there to there is what? 180 minus 3x. Have you seen that? Now, after we get the whole lot of the angle, we can now get the remaining one, which is the smaller one there. Are you seeing that? So the remaining one, which is the smaller one, we are going to say if the total angle from there to there is 180 minus 3x, and we know that the angle from here to here is what? 90. How can we get the remaining one? We say the total minus 90. Are you following there? So we are going to say angle, which angle are we getting there? Angle OTY. So angle OTY is equal to 180, is equal to this bigger angle minus the what? The smaller angle. So we are going to say this is equal to, the bigger angle is 180 minus what? 3x. Is that okay? Minus the smaller angle which we are subtracting is what? 90. So minus 90 like this. And then we are going to say angle OTY is equal to 180 minus 90 is 90. So we have 90, then minus what? 3x like that. So what we are going to have 90 minus 3x, which is which angle? This one here is the, this one here is 90 minus 3x. Have you seen that? Now after getting that as 90 minus 3x, what we are going to do is again, we are remaining with one angle. Which angle is that? This one from here to there. Are you seeing that? So to get that one also, it is very simple, because you know that from here to here is what? From here to here is 90, because we know that this is radius touching the tangent. So meaning that from there to there is 90. So if you know that from there to there is 90, and the smaller angle is already known, we can now get, we can get the remaining one there. Is that okay? So now we are going to say which angle is that? The one we are getting is angle YT what? BI. So angle, so this is this. We've also gotten that. So we are going to say angle YTB is equal to, we are getting this angle here, YTB, which is the angle from here to here. We are saying for you to get this angle, you say from here, we are getting from here to here, not so? Now we are saying that from here to here is what? 90, not so? Because this is a radius perpendicular to tangent, which is a 90 there, so you write 90, okay, minus, are we following there? Minus, we already know that from here to here is what? 90 minus 3x. So we are going to say minus, but as you are bringing it, you should put it in brackets because it is like a function. So it is 90 minus 3x like that. Is that okay? So meaning that now we are going to have our 90, we distribute the negative inside there. So we are going to have 90 minus what? 90. Then plus what? 3x. Have you seen that? So that our angle YTB is going to be 90 and 90 will go away, remaining 3x. So meaning that our answer is what there? 3x. So the angle from here to here is what? 3x like that. So meaning that all the angles now are found. After you found all the angles, so when you find this question in the exam, what you do is start by calculating all the angles inside on your answer sheet. You just show them like this. And then after you've showed them the angles, after you've calculated everything on the answer sheet, then you now come here to say, therefore, then you go to the answer to the questions now. The first question was find what? Angle XYT. Where is angle XYT? XYT. We found what? 2x. So you come and write that it is equal to 2 what? X. Then you go to Roman numeral 2. You say we are getting angle what? YTB. Where is YTB? YTB. We've gotten what there? 3x. So you write also y angle YTB is equal to 3x like that. Then you go to Roman numeral 3 where they're saying find angle OTY. So Roman numeral 3 we are saying find angle OTY. What is angle OTY? OTY is 90 minus 3x. So you write 90 minus 3x. Then from there, number 4, they are saying find angle what? AXO. Where is A? A here. XO, which is this angle there. We go to what? 270 minus 5x. So you write angle AXO is equal to what? 270 minus 5x. So like that, meaning that you've answered the angles in that circle. Yes.